All right, so let's just do a quick recap for how to use a video lesson. If you're going to do a video lesson, one of the best parts of it is that you can pause it when you get distracted. If you have to go to the washroom or something, make sure you take the time to pause it so you don't miss out on any of the information that's being covered. Also, you can rewind, and this is a really important part of video lessons. So if something is said that you don't understand, you don't know where a diagram came from, any of those types of things, you rewind it and go back and look. Okay, that's an advantage that video lessons have over live teaching. So if you were distracted, missed something, you can take charge and rewind the lesson to see what you missed. Okay, so welcome to Maths with Mr. Childs. So our goal for today, I want to be able to add and subtract combinations of positives and negative integers via the zero principle. So you can see right here, the zero principle states that a positive and a negative value cancel each other out as long as they're of the same magnitude. And this is something that's pretty common to understand. If we have a positive one and a negative one and we bring those together, those would lead to 0 if we added those together. So that's the idea of the zero principle, and we're going to use that both with regular integers and with algebra terms. So something we sometimes use are integer chips, and I do this quite regularly. I will start right at the basics, and we will build up to faster, more difficult ways of solving problems. So bear with me if this seems really simple or trivial. I have a plan. You're just going to have to trust me and build these little things into your knowledge, because we'll take advantage of them later on. So using integer chips or two-colored counters, if I want to show 0, what's really cool here, oops, let's not do that. Put our pen down and try that again. This would be 0, okay, because I have one positive and one negative chip. This would also be 0. So as long as I have the same number of chips on both sides, both in the positive and negative column, that's a 0. So if I want to show positive 3, this would be one way of showing positive 3. So these two yellow chips and two red chips at the top, they don't count for anything because they're zeroing each other out. It's only the unbalanced chips right here that make up the 3. If I want to get to negative 2, I've got a couple of options. I can take all of this side right here and delete it. That would be negative 2. I could also add 0 pairs in. That is still negative 2. Okay, so we're going to use these to do a little bit of adding, and then eventually will lead to subtracting, and please stay with me because there's a few traps along the way. So something like 3 plus 4, we would say that as 3 positive chips plus 4 more positive chips. So if you bring down 3 positive chips, then you bring down 4 positive chips, and then we count them all up, we should get 7, and we should be very comfortable with that. Next one, negative 5 plus 3. So we have to go back here, get rid of all these chips, and start with a negative 5. So something like this. There's my negative 5, and now I want to add 3 positive chips. So I'm going to add 3 positive chips. Okay, and if we sort of match these up or line them up, it helps us visualize what we have left. And you can see that all of these chips down here, these all zero out. So we are left with 2 chips that are unbalanced on the negative side, so the answer here is negative 2. And that seems kind of easy when you watch it, but I will see lots and lots of people that will do some miracles here and come up with positive 2. Okay, third one, 6 plus negative 2. So this is just a slightly different way of writing this. So let's grab all of these things right here, and we'll get rid of all of them. Oop, I even lost my line down the center there. Let's put that back. So 6 plus negative 2. So if I take 6 positives, and now this, because I have a nice bracket there and the addition sign, 1, 2, 3, 4, 5, 6, this says add 2 negative chips to this collection. And then the top 2 terms right here will disappear. These will be zeroed out, and I'll be left with an unbalanced amount of positive 4. So that's how the zero principle works. That's how the integer chips works. And now we're just going to take advantage of it to try and iron out a couple of the mistakes that people make quite regularly in working with integers and small algebraic expressions, which is going to be our first few weeks. Okay, so if we have negative 1 plus 4 plus 2, I'll do the first one with you, and then you're going to do the next ones. So there's -1. Then we add 4 positive chips. And then we add 2 more chips. And then we can see right here, these guys would zero out. We would count these up here. We have 5 unbalanced positive chips. So the answer here would be +5. Okay, so if you'd like to take a second, pause the video. This is a good thing you can do. You pause the video here, try the next 2 on paper, and then I'll take them up. Okay, so let's take these up now. Get rid of my last chip. So -3 plus 3 more negatives plus 6 positives. And if we match these up here, they all zero out. And so what we come up with is an answer of 0 here. Okay, so hopefully you got that. Let's take a look at the last one. 7 plus -2 plus -6. Okay, so I'm going to just get rid of all that ink at once. So 7 positives. 5, 6, 7. Add 2 negatives. There we are. Add 6 more negatives. 1, 2, 3, 4, 5, 6. And then we go through and see what zeroes out. Canceling off, and we look like we have 1 unbalanced negative value, and we would get a -1 there. Now this isn't the only way we're going to solve these problems. We'll have faster techniques in the future, but this is to make sure you understand the concepts. Okay, because eventually we start mixing in algebraic expressions, and that's where people start to get a little bit lost. Okay, so let's try a couple more here. We've got some subtraction. Now this is where things we have to be very careful on. The first one is 5 minus 3, so that's 5 positives. There we are. And now -3, that actually means take away or subtract 3 positive chips. So if I take away 3 positive chips just like this, and I get rid of them, I have an unbalanced value of 2 positive chips. Okay, that seems pretty comfortable. Lots of people are very happy with that one, so that's good. Let's go to the second one. 3 minus 3, so that's 3 positive chips. And now take away or subtract 3 positive chips, and not a great big surprise here, but the answer there is 0, so we should be happy with that one. Now the last one is important, because this is the one that lots of people make mistakes on. And it seems quite simple, but a lot of people read subtraction in the wrong direction. Okay, and the direction you read subtraction makes a big difference. So here is the 4 positive chips that are outlined as the first term. Now it says take away 6 positive chips. Well, if you look at my expression here, I only have 4, so I can't take 6 away. But what I can do is I can put a 0 pair on, just like that. And now there are 6 positive chips that I can actually take away. So when I highlight those 6 positive chips and I delete them, I get an unbalanced value of 2 negative chips. Okay, and this is really important because a lot of people will read subtraction this way. They'll say 6 minus 4 is +2, and they will get the incorrect answer. So do not change the direction that you read the subtraction. Okay, you have to read from left to right. It's very, very important. Okay, so let's have a little comparison of these two. The first one is 5 plus -2, so 5 positive chips plus 2 negative chips. And we should see that these here zero out, and we have 3 unbalanced positive chips. If we look at the next question here, it looks very similar. 5 minus +2. So we have 5 positive chips here, and I'm going to take away 2 positive chips. And I am left with, oh, lo and behold, the same answer, +3. Okay, so what we want to start to notice here is maybe there's something about this. If I can get my highlighter to work. Highlighter, you going to work for me? All right, maybe not. Oh, there it goes. And something, oops. Come on, highlighter. There we are, except now I've got green all over it. See, technology gets everybody. So there's some connection here we want to try and link together. Okay, so adding a negative value gives the same result as subtracting a positive value. So please check that together. Adding a negative value gives the same result as subtracting a positive value. So when you see things in red boxes that are very important, so take a second, write this down somewhere important just so you have an example. So we have 5 plus negative 3 is the same as 5 minus positive 3. Okay, and sometimes this will allow us to simplify questions so that it's easier for our brains to handle. Okay, so this is a really important piece of information to have. All right, so let's try some tricky ones here. So we're going to start with, make sure I'm on my pointer there, 0 plus 4. So I don't have to have any chips on here, that's a 0. If I add 4 positives, then my answer is 4. No problem. That one should be kind of easy. Let's go to B. B starts to get a little trickier, at least conceptually. So 0, that means you have nothing, and then take away 3 positives. Okay, so that's a little bit tricky. So what I'm going to do is I'm going to actually start with a different form of 0. I'm not just going to have a blank page. I'm going to put my zeros out there looking like that. Now it says take away 3 positive chips. Well, because I've set up my zeros this way, I can actually take away 3 positive chips, and I get the correct answer of negative 3. And again, if you read this in the wrong direction, if you read from right to left and you read it as 3 minus 0, you just write in positive 3 and you are incorrect. Okay, now the last one is the super tricky one. Okay, and this is the one that gets lots of people. This is the whole reason I do integer chips, just for this type of problem. So we have 0, and we're going to subtract negative 1. Okay, so if you're going to take away a negative 1, so you can see here on my screen I have a 0 set up. If I take away this negative 1, I am left with a positive 1. Okay, so 0 minus negative 1 is positive 1. Now that guy right there causes lots of problems for people all the way to grade 12. So please highlight that. It's going to be our focus for the next slide or two. All right, so let's try a couple more. Negative 2 plus 4. Okay, so if you want to pause this and try all of these in advance, by all means. I'll show you an alternate way of drawing these. You don't have to use chips. You can just use whole numbers if you like. So we're going to start with negative 2, and then I'm going to add positive 4. And I should see the 0 pairs at the top cancel out, and I'm left with 2 unbalanced positives. Okay, an alternate way of writing that is you could write 2 over here as a negative, and then we need to have 4 positives, but we don't have to write the 4 like this. We could write the 4 as a 2 and a 2, and that makes it easier for me to see my 0 pairs. Okay, so that's a faster way. If you get larger numbers, you don't have to use the chips. You can just use numbers. Okay, so let's get rid of that ink and get rid of our chips, and we'll move on to part number B there, or letter B. Negative 3 minus 2. So here's my negative 3. Now we have to remember what this means. This is take away, right here, take away 2 positives. Or we can write it as add 2 negatives. So you have a choice. You could do this 2 different ways. If you do it the way it's written originally, negative 3 minus 2, then you need some 0 pairs before you can take away those 2 positives. And when you take away those 2 positives, you're left with negative 5. If you think of the second version here, I've written in red, negative 3 chips plus 2 more negative chips, that still gets me to negative 5 as my answer. Okay? Now the last one, I'll let you try that. So if you haven't already, pause it, take a crack at it. I'll clean my board. Okay, so we're going to start with a negative 1. And again, now this says subtract 6 positives. Well, we don't have any. Or we can think of it as add 6 negatives. That's an alternate way of viewing the problem. If I do it the first way, I need a bunch of 0 pairs. There's 3 0 pairs, 4 0 pairs, 5 0 pairs, and then 6 0 pairs. Now if I take away 6 positives, I'm left with negative 7. Okay, and that would be the same for both of those. Okay, here we go. Here's the tricky one that gets people. We'll start with A, 4. There's my 4 positives, minus negative 4. Now I don't have any negatives on here, so I can't take any of those away. So I need to use my 0 pairs. So there's 4 negatives that are 0 paired off. Now I can actually do this problem. So I had my positive 4, which is currently what's presented. Now I'm going to take away 4 negatives. So if I highlight the 4 negatives, get all those negatives, and then I delete them, you can see I'm left with 8 positives. Okay, and that really messes people up. These two negative signs in here together is when you have to stop the whole problem and go really slow so you don't make silly mistakes. Okay, if you want to pause it and take a guess at the next two, that would be a great idea. I'll clean my board. Okay, so part B, 2 minus negative 3. Well, I have my 2 positives, but I don't have any 0 pairs, so I'm going to bring some 0 pairs down. There they are. Now I can take away my 3 negatives. So I take away my 3 negatives, and I get positive 5. Okay, now you might start seeing a shortcut here for those of you who are really paying attention. That's awesome. Don't yell it out just yet. Let's do the third one. Here's my negative 4. Now let's read this carefully. Start with negative 4. Take away a negative 1. Do I need to use 0 pairs on this? And the answer is no, I don't. I actually have the negative right here. That's what I have to take away. So when I take that one away, I'm left with negative 3. Okay? All right, so let's try and bring together this little shortcut or thing we have to watch for. 5 minus negative 2. So if we do 5 positives, okay, take away 2 negatives. I don't have them, so I need some 0 pairs to do that. Now I could take away my 2 negatives. Boom, they're gone. And I end up with 7 positive chips. If I compare that with 5 plus 2, so there's my 5. If I add 2 to that problem, I get the exact same answer. So there might be some sort of connection that I can do with these guys right here. See if my highlighter is going to catch up to me. Come on, highlighter. Well, maybe not. Okay, so there is a link or a connection or a shortcut we can take advantage of. We're going to do it. There we go. My highlighter was a little there. Let's backtrack there. Highlighter eventually worked. Just a little bit of lag. Okay, so there's some connection between these. The 5s are the same. The 2s are both there, although their sign has changed. And the operation has changed. That's whether it's adding or subtracting. So if you look here, red boxes, important. So we want to make a note of this. Subtracting a positive number gives the same result as adding a negative number. Okay, so subtracting a positive number right here gives the same result as adding a negative number. Subtracting a negative number gives the same result as adding a positive number. So look at those 2 negatives together, and look at that guy, turned into a positive. Okay, so that's worth pausing the video, writing that down, highlighting it. That is a huge mistake that people make quite regularly from now till grade 12. Okay, so if we could cut it off now, that would be awesome. Okay, so take a pause here. Take a shot at these and see what you can do, and then I'll take them up. I may not use the chips for everything. We might start to be able to get a little quicker. Okay, so let's have a look. Now, first one, 2 plus 6. I feel pretty comfortable that I can do that without chips. That's 8. Okay, now 8 minus negative 4. So if I went over here, and I don't even need the chips, we'll do this without. Say I have 8 positives, and now this says take away 4 negatives. Well, I don't have any, but I could write down my 0 pair like this. I don't have to use the chips all the time. So now if I want to take away 4 negatives, I take those away, and then all I have to do is total up this amount, and I get 12. Okay? If you want to try some other techniques, one other way you can write this as you get more comfortable is this is 8. Now, subtracting a negative is the same as adding a positive. Well, what's 8 plus 4? Well, it's still 12. Cool, cool? All right, so let's do part B. Ooh, and we start with two negatives together right here. Immediately, that makes me nervous. So I would want to do something with this. I'm going to get rid of that other ink. So I would say 8 subtracting a negative 3. Well, subtracting a negative is the same as adding a positive. Okay, and I would deal with this guy right away. And then I could go 8 plus 3 is 11, plus 1 more is 12, and I come up with the right answer. And again, I can do this with chips if I need to. I might do it on the last one, C. It's got some tricky numbers in it. So we start with a negative 5. So let's start with negative 5. Now this says take away negative 1. Now I don't want to be too hasty to start jumping into zero pairs. I want to think this problem through. I have 5 negatives, and it says take 1 away. So if I highlight 1 and delete it, I'm now down to negative 4. Okay, so those two terms right there would turn into a negative 4 minus 3. Okay, so this is turned into this. Now, if I have negative 4, subtract 3 positives. Okay, well I don't have any. Or could I write it this way? Subtracting a positive value is the same as adding a negative value. So if I wrote it the second way, then I can drag 3 negative chips down, and I end up with a total value of negative 7. Okay, so if you take the time to use the chips and go slowly, the stuff isn't that terrible. But if you try and go quickly, lots of people make really silly mistakes. Okay, so let's just go over some old concepts. Break the following down into ones, tens, and hundreds. So 125 would be a 100 plus a 20 plus a 5. That should be pretty comfortable. Negative 24. See, a lot of people will do this because they'll follow the previous one. But if you added these two values together right here, that's actually negative 16. So you have to be very careful with negatives. This shouldn't be adding 4, this should be subtracting 4. Okay, so that would be one way to break those up. So negative 88 would be a negative 80 minus another 8. Okay, so break the larger numbers into their parts. So we're going to evaluate, which means find an answer. So what we can do is break these numbers down. So I might turn the 78 into a 70 plus an 8. Minus 64, I might write that as negative 60, or minus 60 and minus 4. And then I might let these two terms play together. So 70 minus 60, that's just 10. If I look at these two, I have a positive 8 and I subtract 4. That is positive 4. And then if I bring those last two values together, I get the answer of 14. And this is good mental math practicing. You wouldn't necessarily do this in all your questions, but this is things you can kind of do in your head to start figuring out answers. 146, you could break down like that. Now I might do a little strange bookkeeping here. I might do something like that. Okay, and you could probably start to see I'm lining my tens up, my ones up, and my hundreds up. And now negative 45. That's a minus 40 and a minus 5. And now again, this isn't what you have to do. This just might be something you find is useful. But it allows me to collect some of those terms all into neat little bundles. So there's nothing affecting the 100 right now. If I look at the tens, I have 40 plus 20 more is 60. Minus 40 gets me back down to 20. Okay, and now here's the tricky one. 6 plus 4 is 10. Minus 5 more gets me back down to 5. And then when I add all those up, I get 125. And that's just a slightly different strategy you can use from time to time that'll help get answers fairly quickly. Traditional methods or columns. Most of the times you'll probably see something like this. Okay, and it's very similar to the technique I just showed you. It just has a different bookkeeping strategy. So if we add up the ones, 5 plus 9 is 14. Well, we could write it right like this. Okay, that's one method you may have been shown. Normally, though, what you'll see is a lot of people will keep that value of the tens, and they'll keep it as a placeholder here. So the 14 becomes 4 ones and one more group of 10, and so they write it on top. Now 8 plus 4 plus 1, those are the number of groups of 10s, so 8 and 4 is 12, plus 1 more is 13 groups of 10. But as soon as you have 10 groups of 10, that's another group of 100, so the placeholder moves over. Okay, and we'd have 434. You can do multiple numbers, which is why a lot of people like the column approach, because you could just keep adding on numbers and keep bringing them all together. So if we start in the ones column, 5 and 9 is 14, plus 2 is 16. We bring the 1 over as a placeholder. 3 and 5 is 8, plus 6 more is 14, plus the 1 on top is 15 groups of 10. Okay, so I have to keep that track of that group of 10, which became 100, and then 1 and 1 becomes 2. Okay, that's traditional or algorithm approach. You hopefully have seen that at some point. Subtracting, got to be a little bit more careful. The way you write it is important. So we would set it up very similar, and we would subtract the bottom number from the top. So you're starting here and looking this way. So 4 minus 2, okay, is 2. 5 minus 4 is 1. 1 minus nothing underneath the ones there. There would be a 0 there. Oh, sorry, a 1. Silly me. The 0 is up a line. So we would end up with 112. Okay, now this one here has the dangerous stuff in it. Okay, so if you have 8 minus 2, that's 6. Now here's where we run into some problems. You can't subtract a 9 from a 6. You'd have a negative value, and it doesn't work really well in the algorithm. So what you're traditionally shown is you borrow from this column and bring it over. So instead of viewing this as a 6, you view this as a 16 now. So 16 minus 9 would be 7. And we've used up our hundreds group. We put a 0 there now because we no longer have a group of 100. Okay, so we have a little task to try. Give that a whirl. And thanks for tuning in.